What if I told you the secret to keeping our modern internet running, the thing that makes your favorite apps just feel like they're always there, wasn't cooked up in some Silicon Valley lab? What if it was actually discovered in the ruins of an ancient civilization? It sounds a little crazy, I know, but today we're diving into a brilliant paper that uses this exact idea, a kind of fictional archaeology, to explain one of the most important algorithms in all of computer science. And it all kicks off with this quote. It's about a supposed archaeological find on the Greek island of Paxos. The whole paper is framed around this story of a parliament full of, part-time politicians who are constantly wandering off. It's a fantastic little narrative, but don't let the story fool you. It's also a really precise metaphor for a very real and very complex technical problem.
So, yeah, that's the big question here. How on earth could a system designed for forgetful people and slow, unreliable communication possibly hold the key to building some of the most dependable digital systems in the entire world? Well, the answer, as you'll see, is it's surprisingly elegant.
Okay, so first, let's set the scene a little bit. The paper asks us to imagine ancient Paxos. It's this bustling hub of trade, a real mercantile center. And here, yeah, civic duty was important, but let's be real. Business was more important. And that meant the legislators were always coming and going from the chamber, which created this really unique challenge for just getting anything done.
So this is the puzzle they had to solve. How do you pass laws? How do you maintain a consistent legal record when your government is just in a constant state of flux? How do you make sure that the laws passed by one group of people don't completely contradict the laws passed by a totally different group that wanders in an hour later?
Let's dig into the specific rules of this ancient parliament. Because the system the Paxtons came up with, it had to be incredibly robust, right? It had to handle the truly chaotic nature of their government.
Now, the key to their whole system was the ledger. Get this, there was no central secretary, no single source of truth. Instead, every single legislator kept their own book, their own personal copy of all the laws. And the main goal was to make sure that, eventually, every single one of these ledgers was completely identical and correct. And this sets up this fundamental tension, On the one hand, you absolutely need consistency. You can't have one legislator's book say, Decree number 132 is about olive oil, while another says it's about building a new road. That's just chaos. But, at the same time, you also need progress. The parliament has to actually pass laws for the society to function. You can't just keep all the ledgers blank forever just to stay consistent. And this is where it gets really cool. These ancient challenges, they're perfect mirrors of modern problems in computer networks. A legislator just up and leaving, that's a server crashing. A slow messenger, that's network latency. A lost message is a dropped packet. And two different groups passing conflicting decree number 37, that's a classic